Hello, everyone, and welcome back to a very special edition of the Kohi Game Engine series, where today, if you haven't already gathered from what you're seeing on the screen, we are going to tackle something that has been on my to-do list for quite a long time, literally over a year, probably a year and a half since we started the series or so. This is the 76th video in the series, at least the 76th main video, not counting all the sort of in-between patch videos I did. And so, if you haven't guessed already, today is going to be the day that we are going to port Kohi to macOS. And we're also going to revisit our build system because we are adding yet another platform and it's getting kind of crazy to manage. So we're actually going to be changing up a lot of that stuff so that we can simplify our build system and get rid of a lot of the duplicated efforts that are being done there and make it a whole lot easier to maintain and work with. So I'm going to basically start this off as if you have a brand new Mac that isn't set up for this at all. And of course, my Mac here is set up, even though this is a brand new machine, as you guys will have seen in the unboxing video that I released before this. I have already configured this machine to work with what we need. So what we're going to do is kind of quickly go over the various things that you're going to need, and then from there we will get into the meat and potatoes of things. So the first thing that I want to do is I want to pull up a terminal, and I'll clear that because I don't know what all that stuff is. So the very first thing is, and actually before we do any of this, I do want to point out that this video is being recorded on a 4K-ish screen because this is the only screen that I have in the house that actually has this display resolution. So let me know what you guys think. If you guys like the higher resolution, let me know, and I can record on this device going forward, at least until I get a 4K monitor on a different, for my desktop. Or, if it doesn't matter, just let me know that too. But anyway, so the very first thing I did before doing anything else was I went into a terminal and I typed Clang. And Clang should be installed on macOS by default, so it should already automatically be there. Now I'm going to get this message here that says Clang, no input files, which means it's installed. We just didn't actually provide it anything to actually compile, which is fine. But what you're more than likely going to get if you haven't set your machine up yet is it's going to give you a series of prompts to install developer tools, and you're going to want to go ahead and do that. And then doing that, it will go ahead and set up everything that you need. It'll make sure that Clang is there, any of your things like Git and whatnot, all those things should be installed along with that, along with Xcode, if I remember correctly. And so you'll want to go ahead and do that first and foremost. I'm going to go ahead and close this terminal because I don't actually need it now. The next thing that we're going to do is we're going to need to grab a couple things here. So you're going to want to grab VS Code if you haven't already. And that is just a quick, simple install. And then the next thing that we're going to do is we're going to need to go ahead and grab the Vulkan SDK. And this brings up a rather large caveat. So before we jump into this, I do want to just quickly point out, wait, that's not what I wanted. I wanted about this Mac. Okay, so we are on version 12.6 OS Monterey, and this is a 16-inch MacBook Pro with the Apple One Max in it. So if you guys are following along on a Mac, I know that this works on M1s, but I have not tested it on an Intel Mac because I don't have one to test with. Anyway, so the issue here is, so far we've developed everything in Vulkan. However, Mac does not support Vulkan. They don't support it in any way, shape, or form because they have their own API called Metal. And Metal is a completely different API from Vulkan. They're not related whatsoever. However, the Vulkan SDK actually includes a translation layer between Vulkan to convert everything to Metal commands. And whenever you install the Vulkan SDK, that is what you actually are going to be obtaining. So when you go here to the download page, which is vulkan.lunarg.com, and you come down here and you click the little Apple logo, it comes with something called Molten VK. And this allows us to run Vulkan on iOS and macOS. And so we are going to be leveraging this right off the bat. And the nice part about this is there isn't a whole lot that we actually have to do to get this to run as is, right out of the box. We basically just have to enable a flag and load up an extension. And I think that's about it. There is some other porting work that we're going to have to do in the platform layer because that hasn't been touched, basically, in quite a long time. And so, most of our work will be there in the build system. We're not going to have to do a whole lot to the Vulkan side at all to support all of this. So you'll want to go ahead and grab this and install it. So you'll click this. It'll download a package for you to install, and you'll want to go ahead and do that. I'm not going to walk through that on this video because I've already done it. And there's plenty of documentation on how to get that done. Okay, so that covers most of what we're going to need. And so the next thing you'll obviously want to do is clone the project. Or, if you're following along somehow and you're wanting to follow on a Mac now, you'll want to go ahead and clone your project on the Mac machine. So, with that said, the current solution for Mac does not compile because there is an issue here with the unused function platform console write file. And so we could very easily just come in here to the platform macOS.m file, and we'll go all the way to the top of that guy, and this is what it's bleating about, just because that was there from something that used to be there that's no longer there, because that's handled by the file system now. So we could actually delete that, but it's not going to, it's not really going to save us. So if we build this again, now we have all sorts of undefined symbols, external symbols. So we see here that our mutex stuff, our thread stuff, none of that stuff was implemented. So that is what we're going to have to do first and foremost. So before we jump into that, let me tackle really quickly what extensions we're using. So I'm using the C++ extension from Microsoft. That's for the IntelliSense and syntax highlighting and all that. I have Doxygen in here. That's for auto-generation of documentation. I have GitLens. These two are really optional. I have the Groovebox theme, if you guys are wondering what color scheme I'm using. I have Makefile tools installed here. That is for editing the Makefiles, which we're going to be doing a lot of today. I have shader language support and to-do highlight. So all of these things are available on the marketplace if you want them. All right. So what I think we're going to do is we'll go ahead and get this up and running first, and then we'll tackle the build system redo after this. Unless, actually, you know what? Let's tackle the build system stuff first. So currently what we have is we have a whole bunch of makefiles, right? And then if we look at our debugging tab, we have basically an entry here for each one of these platforms. And we're about to add another one, which is macOS, which is here for some of them, missing for others. And this is going to get super cumbersome. Whenever we go to add additional platforms in the future, like I don't know, say Xbox or Android or iOS, for example, it's going to get pretty cumbersome to manage all of these and then all these separate makefiles. And so what we're going to do is we are actually going to trim this down, and we are going to basically combine a lot of them and switch our logic based off of what our individual platform that we're currently on requires. And so I think what I'm actually going to do is let me just grab my notes real quick. So I think the way that we're going to handle this is I already have gone ahead and prepared most of this ahead of time, because if I hadn't, we would basically be here for a very, very long time. So I'm going to go ahead and just drop in a lot of the files that we have here. So before I do that, I'm actually going to take all of these make files and I'm going to delete them, because we're just going to, it'd be much faster to just drop in the new ones and explain what's going on. But they're basically going to be a combination of these things, right? So we have Linux, macOS, and Windows for each one of these things. And we can see that there's a lot of repeated stuff in here around all these variables, the way that they work, the general layout of the file, things like that. A lot of that stuff is repeated, and it's repeated even more so, like the engine sort of has its own configuration. And then each of these applications, you know, the executables, like the test bed, the tests, the tools, they have all very similar setups to each other. So these are all kind of in one camp, and then the engine's sort of in its own camp as a library. And so what we're going to do is we're going to basically wind up with two make files. We're going to wind up with one for the engine because it's kind of specific to the way that it's built. And then we're going to wind up with one that we can pipe all the rest of these into. And so that should definitely speed things along and help us to basically do this without too much pain. So what I'm going to do, like I said, is start off by deleting all of these. So I'm going to get rid of those, move those to trash. And I'm actually going to close everything, just so we're not bouncing around here in this file explorer, because that's kind of annoying to me. And what I'm also going to do is I'm going to create a new file, and we're going to call this makefile.engine.make, right? And this is purely going to be just for the engine. So what we're going to wind up doing is I'm basically just going to drop in the contents of the file all at once. And you guys will kind of see why I'm doing this. Because if I were to step through this and kind of do it on the fly, it would take a long time. It took me a long time to figure all this out. So what we have here is a combination of make files for all three systems. So the first thing that we're going to do is set up a couple things here, like our build directory, our object directory, our assembly. These are all things that were in the previous version of the file. We're also going to start off our defines collection of flags up here. So for right now, we're going to have kexport defined. And then we're going to detect the OS and architecture. And based off these things, we are going to set a series of flags. So we're going to set a build platform. So if we're on Windows NT, and we can use this environment variable OS to determine that for Windows. So Windows actually sets this, and if it says Windows NT, then that means we are actually on Windows. And I've verified that this works all the way up through Windows 11. So we can detect Windows that way. So we'll say here we are on Windows. Our file extension for the engine will be a DLL. Our compiler flags will be wall, where, WVLA, which is basically a warning if we use VLAs. We do not want to use folding constants. We do not want to... we basically want to use the no missing braces and warn if we're missing braces. And then we need fdecl spec for the import export. And then here we have our include flags. So this is pretty standard as well. We're going to include the engine source directory as well as the Vulkan SDK include directory. The linker flags for this will be, for now we're going to leave this G in there, although I'm kind of thinking, we might not want to do that now. Because we're actually adding it here. Yeah, that actually shouldn't be there. So let me get rid of that. So we are creating this as a shared library, which basically means it's a DLL, not an EXE. We're linking user 32, Vulkan, and then we're setting up the Vulkan directory for that, as well as the engine for the engine's directory for linking. And then we have our defines. We're going to add the underscore CRT secure no warnings because Microsoft Visual Studio or Visual C warns on use of a lot of library functions that we don't necessarily want to deal with right now. So we're going to clobber those. Eventually, we'll probably go back and fix those, but for right now, I'm just going to clobber them. And then make on Windows does not actually offer a recursive wildcard function, and we don't have anything in the shell to actually do that, to search for files by a wildcard. So I've done that here again. I explained all of this in the Windows video, so I'm not going to go into it here. Here we grab a collection of C files, and then we go ahead and get all the directories that have H files in them so we know what to search through. And then we have a collection of OBJ files, which is our object, not OBJ files, O files, which are object files, right? That's our sort of intermediate files. Now we do have some additional architecture detection down here. So we have basically AMD 64. We have two different ways of detecting that because sometimes this works and sometimes it doesn't. So if that's not defined, it falls back to this one. And then otherwise, if x86 is found, then we are saying i32. So we're not actually going to use that right now, but I think when it comes to SIMD and other things like that we're going to be adding in the future, we're going to want to know that. And this is one way we can very easily tell that. So next, we have our Linux and our Mac detection, which are almost identical. So they both use the uname, which most Linux distributions should actually have. If it doesn't, I can add another thing in here to try and detect that. But for now, I'm just going to rely on that. So that's literally a shell where you type uname-s, and it comes back and just says Linux. So it'll either say Linux, or in our case, it'll say Darwin for OS X. So for Linux, the platform is Linux, extension is SO. The compiler flags are set up for Linux. Same with the include flags and the linker flags. Now note here that I do not have debug symbols. I'll come back to that in a second. So we have, for Linux, we have the C files and then the directories with H files. So we can use the find command on this platform, so we don't have to rely on something like this, like we do in Windows. And then we have our object files. macOS is mostly the same. There are a couple differences here. So the big difference is we also have to declare this dynamic lib, and then we also have to declare something called an install name with a @rpath libengine.dylib. So when we compile a shared or dynamic library on macOS, the typical extension used for that is dylib for dynamic library instead of .so. So we'll use that extension here, and we'll call it this, and that is so that the operating system can actually resolve that. So we also link with Vulkan. We link with Objective-C because we actually have to use that. You'll note here that there's also a compiler flag for Objective-C. That is to allow us to use Objective-C, and we'll come back to that in a minute. And then we are linking with Framework, AppKit, and Quartz Core. So both of those frameworks are linked against. And those are to allow us to interface with the operating system. Now, here we actually have two types of source files. We have a C file, which is just our standard C code, and then we have .m files, which is actually a mix, which is what the M is for. It's a mix between C and Objective-C, because we have to use Objective-C to actually interface with these guys here, as well as Foundation. So we have our source file has been modified, so we have two things that are fed to our find command here. So the first of which is a C file, and the second of which is a M file. So we look for both of those, and then same as before, directories with H files and our object files. So ultimately, the M file will wind up compiling and looking exactly like a C file will have once it's compiled, and it'll just wind up as an O file as well. And then we go ahead and perform another uname, this time with -p, to get the sort of platform that we're going to be on. So here we have the x86-64 detection, so we can say AMD 64. And then we also look for 86 for IA32, that's 32-bit. We're not really going to be supporting that, but I'm putting it in there just in case so I don't have to look it up again later. And then we're also going to detect ARM. Now, ARM is the chipset, or the architecture rather, that the M1 chipset is using, which is what I'm currently on. So when it comes to SIMD and whatnot, we're going to need to know this when we get to that point. So that is definitely going to be very important going forward. Okay, so the next thing that we're going to do is we are going to do generation of a version. And this is something that's common in software projects where you version your libraries and eventually your applications, and we're going to start doing that. And it's a little bit different between Windows and everything else, of course. We're going to write a little application that at build time goes ahead and generates a version number for us based off the current date. And then that will give us an idea of when we go ahead and do release builds of when that version was actually compiled. And then from there, we basically run that program and then take that and we're going to feed it into a new newly generated version.h file. So we'll come back and implement that in a bit. And that's basically just going to add a define in a H file that can be included in the application. That'll tell us what the version of the engine is. So here's the Windows version of that. Here is the version for everything else, which is the same for Linux and Mac. Also, we've gone ahead here and we've wrapped all of this in a do versioning. So if do version is set to yes, meaning we want to run versioning against this, we're going to go ahead and run this logic. So we also have something called ver comment, which is a comment that we put at the top of this version file. And then later on, we actually write out the version to that. So we go ahead and declare and set all this stuff up here. Okay, so the next thing that we have here is we have release and debug builds. And for right now, we don't have anything under release that's super special, except we are not defining _debug and -g and -md for the compiler and linker flags. And so for debug, we are defining those things. For release, we're not. Now, obviously, we're going to put some compiler optimizations eventually for release, but there's a lot more work we're going to have to do around that to support that. But this is scaffolding and debug versus release builds. So we have that. Our all rule is, or recipe here is the same. Our scaffold basically now says if Windows, do this. This is the same thing that was in the old file. Otherwise, we're going to go ahead and call makedir -p for the build directory, and then set up all the object directories. Next, we're going to go ahead and generate the version file. So on Windows, that's of course done a little bit differently. So we are going to first delete the file if it exists, and then write out to the version file. And for everything else, we can use rm-rf and remove the version file, and then write out to it. Now, annoyingly, the version of make on Windows requires no quotes around this to be echoed to the file, because otherwise it actually treats the whole thing as a string and jams the quotes in there. However, on macOS and Linux, it does require the quotes here, but they do not get inserted to the file. So that's kind of confusing, and that's why we have separate ones there, is literally just because of that. So scaffold looks pretty much the same. It's just combined now. Next we have link. So we now just say we're linking the assembly, and again we have one version of that for Windows and one version for everything else. The only difference between the two is Windows uses backslashes in its path, versus everything else uses forward slashes, and then the library is actually prepended with lib. So we have assembly here, lib, and this will become lib engine, for example. The compile step looks pretty much the same. We've gone ahead and just added a nice echo in here to sort of make that stand out a little bit more. So that is that. The include D files, which is basically just the cached compilation, so that we're not completely recompiling every single thing every single time we compile. So that's there. Now, the next thing to note is clean. We're actually going to use this engine.make file to clean as well. And we're actually going to be getting rid of these clean scripts as well and just pointing it to this file instead. So we just echo here what assembly we're currently cleaning. And then, of course, Windows has to be different from everybody else. So here is everything for that. That is basically doing a check to see if the assembly with the extension exists and deleting it if so. And then Windows includes a lot of other files that are named after it. There's a whole bunch of other files that get included. I can't actually show you here because I'm on a Mac. But if you are following along on Windows and you build, you'll notice that you get a whole lot more files. This just covers all those files by just doing .star. We also go ahead and we nuke the directory for the OBJ file or the object files. Otherwise, if we're not on Windows, we go ahead and we just nuke the library itself and then the directory with all the object files in it. Next, we have the compilation here for all the C files. So we compile C files to O files, and this is for Windows, Linux, and Mac. And then finally, we have here at the very bottom, if we are on Mac, we have an additional step to do, and that's to capture those M files and compile those as well. So we go ahead and do that. It's basically the same as this. The only difference is it uses M instead of .c, so we need a different block for that. Okay, and then of course we include the .d files. So that is our new engine makefile. So everything for all of our platforms is included there. Now, with that, we also are going to create a new file to compile basically everything else with. And so that file we are going to call makefile dot executable.make. And again, I'm just going to slam the code in here. Now, this is 90% the same as the file we just looked at. However, there are enough differences where I thought it was prudent to go ahead and split this up. So here we have our declarations at the top, and we define a engine link at the top, which is just -lengine, right? And if we're calling this for version generation, in other words, we're building the version generator, that is going to be an application that we do not want to link against the engine. So in that case, we go ahead and blank out the engine link. Okay. So we're only going to link with the engine if we're not on version gen. And we haven't created version gen yet. We will get to that very shortly. But that is basically going to be a small application that we don't want linked against the engine because the engine actually requires it to run. So it has to be built first, and it should not be linked against the engine. It's very small, very lightweight. So we have that. Again, we do our standard OS check. Everything here is the same except it's just not a shared library, right? So we don't have all the RPath stuff and all that. Let's see. I think the only other difference is we don't have M files within any of the executables because we're going to keep all of our platform-specific stuff, which would require the Objective-C M files. We're going to keep all of that in the engine. We're not going to have the applications do any of that. Now, if the user wants to create an application that does that, that's up to them. But as far as our architecture goes, that's all going to be abstracted away in the engine. Okay. So I think other than that, this is pretty much the same thing. So it just inserts this engine link here within the linker flags. So that'll either be blank or it'll be, this L engine. And of course, Windows being Windows has to do things slightly different. So Windows requires the lib extension for that. So if we are building this on Windows and we are linking with the engine, meaning this is not an empty string, that's what this check here does. This comma and then nothing after it signifies check against an empty string. So we're saying if engine link is not an empty string, then we're going to go ahead and set engine link to engine link and then .lib. So we're just going to pen that .lib there. And then that's going to be right here in our linker flags. And for the reference, adding a linker directory here doesn't really matter because we can just add that and then it just doesn't link against it. It's just so the linker can find it at link time. Okay. So we have all of our platform detection just as before. If we need it for anything, we shouldn't need it at this level, but we might. And then we have our release debug stuff here. So that's the same as before. Our scaffold is all the same. Our link is all the same. Compile is all the same. We just spit out a little bit more information here. So we say performing, so the assembly, we write out the name of the assembly. So that's going to wind up being, test bed or tests or what have you. And then target. Target is essentially going to be the debug or release, right? So we have that here. We're going to be passing that in. And it'll basically say something along the lines of performing testbed debug build or performing testbed release build. And I've gone ahead and added some dashes here just to sort of make it stand out in the console. Next, we've gone ahead and done the same with clean. This is exactly the same as it was before. And then here we are compiling our C2O object for Windows, Linux, and Mac. So we're only handling that. And that's it. So we're just going to be passing in some things to this to signify it. You'll notice there is no assembly at the top of the file. Assembly is a variable that we pass when we're calling the make file. So we tell it that on the way in. And that keeps this super, super flexible. Okay. So the next thing is probably going to be let's tackle the build all. So we have build all macOS. I'm going to delete that. We no longer need that. We also don't need these clean scripts. So those can all go away because we're going to be combining those. So here's the build all sh. And this is largely going to look the same. But I'm going to drop in a new file anyways so that we can have a look at what our updates are going to be. Okay, so we are going to be parsing 3 arguments. There are going to be 3 arguments passed into this this file, and the same is going to be true for the batch file. We're going to pass the platform as the first argument, an action as the second argument. That's either going to be like build or clean, basically. And the third is going to be the target, okay? And that is basically going to be Windows, Linux, or Mac, okay? Or was that, actually, I think that's debug. That's actually debug. Right, yeah, that's debug. Sorry, not Windows, Linux, or Mac, but debug or release. And so this basically just says, okay, if the action is all or build, we're going to use build. Then we go ahead and we set action to all, action string to building. This is just for console output. Action string past, that's the past tense of what we're doing here. Again, that's just for console output. And then whether or not we are going to be doing a versioning call. So if we are building, we are going to use versioning. If we are cleaning, we are not going to use versioning because that doesn't make any sense. Why would we version a clean? So that is where that do version comes into play. And then if for some reason we pass some sort of weird action that isn't covered by these 2 cases, then it's going to say, hey, you bananas, what are you doing? You know, we have an unknown action here. Can't do anything with it. So the next thing is we'll say either building or cleaning everything on platform. So it'll be, you know, whatever platform we pass in, and then the target. So it just kind of echoes that information for us. And then it goes through and goes ahead and calls our make-f and then passes the executable makefile. So we're first going to build that. And we are going to pass action along. So that's either going to be build or clean. Target is going to be our release or debug. That's not really going to matter for clean, but it will matter for build. And then our assembly is going to be version gen. Now, again, we have not created version gen yet. That's actually going to be the next thing we're going to do. But this is important to be built first because our engine makefile actually makes use of that version gen utility. So from there, we are going to then build the engine. So the engine takes a little bit more. We're calling makefile engine.make. We pass the action, the target. We are also passing a major version of the engine, a minor version of the engine, and then whether or not we are doing the versioning. So this is the only library for right now that is going to be using the versioning. If we decide later that we want to do that for the other libraries, we can certainly add that here. But for right now, it's just going to be for the engine. Okay, so finally, we just have 3 more calls to our executable makefile here. The only difference between these 3 is testbed, tests, and tools. Okay, and so now we're just reusing the same files and we're just passing different variables to it, which is a lot cleaner. And then we say here at the bottom, all assemblies using past tense action string successfully, so built or cleaned successfully on platform and target. And that's it, right? So that is basically what our new build system looks like. Okay, so I guess let's move on to this version gen, because this is something that we have now discussed several times and have not actually done yet. So let's go ahead and create that real quick. This is going to be really quick and small. So I'm going to go here and add a new folder to the base. So I'm going to call this version gen for version generator. And in there, I'm going to add another new folder called src. That's where we're going to put our source. And in there, I'm going to put a new file, and I'm going to call this main.c. And I'm going to paste some code. And let me actually get rid of this terminal here. Let's get that out of the way. Go away. All right. So here we're going to use just the standard library functions because this is just a utility. We just need something quick and dirty. We don't care about necessarily the runtime performance of this. So we're going to use standard IO, time.h, and stdlib, or standard library. Our main function is going to take 2 arguments, so it requires that. So we're basically going to say version gen, major version, minor version. And then what this is going to do is going to create something similar to, like, if you pass 1.3, it's going to create a major.minor.build.revision. Okay, and it's going to do these 2 based off of the current date and time. So it bleats if we don't pass it the things it's looking for. Next, it goes ahead and parses the first and second arguments. And then we go ahead and we obtain the local time. I'm just using this for now. I suppose we could switch this to UTC at some point, but for now I'm not really too concerned about it. It's not like the major and minor versions are going to be based on this. It's just for the build and revision. So the build is going to be the last 2 digits of the year and the day of the year. So today I think is like 2/22 or something like that. And then the revision is going to be the number of seconds since midnight. So the revision here is basically the current hour times 60 minutes times 60 seconds plus the current minute times 60 seconds plus the current second. So that's going to give us the total number of seconds, which will be a 5-digit number max. And then we're going to print using this format string here, a number dot a number dot a number prepended by at least a single 0. And then again, a number prepended at least by a single 0. And then a number prepended by however many zeros it takes to make it be 5 characters. Okay. So what we're going to do is we're going to take major and minor for the first 2. We're going to take the year, and we're going to basically divide that by 100 and get the remainder, which will give us 22 in this case. And then we're going to go ahead and grab the Y day, which is the day of the year. That is for this guy right here. And then the revision, we're going to take this number that we calculated and pass that into the last one. And that's it. That's all there is to that application. There's really not a whole heck of a lot to it. Okay, so I believe that is, oh yeah, this post-build macOS, we're actually going to get rid of that as well. So let's go ahead and bin that. Okay, so the next thing that we'll need to do is we actually need to perform some cleanup in some of our libraries. So Engine, for example, has these build scripts. These things are completely, totally out of date and wrong. So we are just going to completely get rid of those. And I think there was one more library that had these. Yeah, testbed had these as well. These are completely out of date and wrong. We're not going to build things that way anymore. And I don't think, oh yeah, tests has them too. So we're going to get rid of those. And tools doesn't have it, and version gen doesn't have it. So basically what we should see is this, this library or application / source, because the source is the only thing that's actually in that folder. Okay. Let me just check something. Okay. So the next thing that we're going to do is we are going to set up our tasks in our launch to use our new system. So right now in our tasks, we have all these build definitions. So we have build engine, build testbed, build unit tests, build everything, clean everything, and then post build. And we're going to be keeping most of those, but we need to refactor them somewhat. So the first thing that we're going to do is, again, I'm just going to, for the sake of time, drop in the updated version. So what we're going to do here is if we want to build the engine explicitly, we are basically going to call what the batch file calls, or the bash script, as far as actually, I don't think we actually edited the build all.batch file. I'll have to come back to that. So basically we're just calling make against the engine make file, right? And actually, I just realized these are actually incorrect. So what we actually need to do, how do I want to handle this? I think for now I'm just going to get rid of the ability to build these individually because we don't really need to do that. Yeah, let's just do that. We can always add them back, but there's too many variables and things like that to update. So for the sake of brevity, we're just going to basically have a build everything and then a clean everything. So we're going to basically call the bash script, the sh file, unless we're on Windows, and then we're going to call the batch file. So for each one of these platforms, we're going to pass along some arguments. So we have the platform, the action, and then the target. Right? So we have Windows build debug. For Linux, we have Linux build debug. For OS X, we have macOS build debug. Right? And these things are automatically picked up by VS Code as to which one you're currently on. So it automatically maps to whichever system you're on so that it runs the right one. So it works basically the same way for both of these. The only difference is for clean everything, instead of saying build, we pass clean, right? So here we just say Windows clean all, Linux clean all, macOS clean all. And that is pretty much it for the tasks. So let's jump back to the batch file real quick. Because I need to adjust build all, that batch file, because that has also been updated as well. So it's going to look remarkably similar to the shell script that we wrote. So it's basically going to say if we received build, then we're going to go ahead and build. Otherwise, we're going to clean. Otherwise, it will abort. Now, our action, I could have swore I actually passed all in the Windows version, which is probably actually wrong. Did I? No, I got it right. Okay, so this is build, and then this all here doesn't actually matter for the clean. It's not actually used. Okay, so this basically says, okay, are we building or are we cleaning? Sets basically all the same variable names, just in a batch file instead. And then goes ahead and calls executable make for version gen, engine make for the engine, passing the same version flags and all that stuff. And then calls executable make for testbed, tests, and tools, and then spits out a message at the end saying all assemblies, action string passed successfully, platform target. Okay, so that is that. All right. So we have that. The next thing that we need to address actually is really this long list of things here. So we have this entire list of all these launch targets, and that really needs to change. And again, for you guys that aren't using VS Code, this doesn't really matter. But for anybody that is using VS Code, it absolutely does matter. So what I'm going to do is, instead of having duplicates of all these, again, I'm just going to set up the automatic detection of the operating system that VS Code gives us and swap out appropriately. So again, for the sake of time, because this is a really long file, I am going to go ahead and paste this in and quickly explain it. So we have just launch testbed right now. So we just have launch testbed, launch unit tests, and launch Kohi tools. And that's it. The version gen will be launched automatically by the build process, so we don't need to do that. So the testbed will by default use CPP debug. Launch stop at entry is false. All these things are common across all the platforms, with the exception of this that gets overridden. And then we have the program here, which is defaulted to just workspace folder bin testbed with no extension. And that's because that's the same between OS X and Linux. So OS X needs the MI mode to be LLDB for debugging purposes. And I have the target architecture here set to ARM64. If you are on a Intel Mac, you probably will need to set this to x64. But obviously I'm not going to do that. So I would like to find a way to actually be able to do this on the fly, but I don't actually currently have one. So I may wind up having to have separate build targets, but since Intel Macs are going to be a thing of the past, I don't know if I'm going to bother. Okay, so we also have for OS X external console false, and then for Linux we also set that. However, for Windows, of course, it being Windows, everything has to be a little bit different. So for Windows, we use CPP VS debug, and that is for the Visual Studio debugger on Windows. So if you're using GDB on Windows for some reason, like you're compiling with MinGW or something like that, you'll probably want to swap that back to CPP debug. Anyway, the program is set to point at the executable, and then CPP VS debug actually requires this console integrated terminal instead of external console. If you try to use external console false, it will actually warn you that it's deprecated. So on Windows, you actually have to do this completely different, which is fairly typical for Windows. The other thing that I do want to point out about all this console stuff is currently, because of some limitations on the debugger and I think actually LLDB itself, there is currently no way to output the game's output to the terminal. It has to output to the debug console. And that's very unfortunate, but there really is no way around it. I've researched it, and currently there's just no way around it. So once we get this up and running, we'll kind of cover that. But I just wanted to bring that up while we're in here. So unit tests is basically the same thing. We're just pointing at tests instead. So either tests exe or just the tests executable file. Same with the Kohi tools, right? And that's the Kohi tools is basically going to default running the build shaders that it always has. You can always change that if you want to test it. Okay, so that is it for the launch JSON. So I believe we could probably clean, and we should be good. It should work, right? It's cleaned out that OBJ file. We don't know that it cleaned the bin because that's already been cleaned out, but we have cleaning version, gen, cleaning engine, testbed, tests, and tools. So we see that all those things are working. And then I think we should be able to go ahead and build. So I'm going to go ahead and do that. Oops, build. And we should basically be right back to where we were. Okay, so now we have to jump into the bit where we actually have to modify the platform layer. for macOS, right? Because we're missing a whole bunch of stuff. We don't have any of the threading stuff, and we don't have any of the mutex stuff either. So we're going to have to add quite a lot to this file. And I also noticed that a lot of the key mapping that is actually done down here is completely wrong. So what I'm actually going to do is I'm going to drop in the changes that I've made to this file and sort of run through them real quick, because that is going to be a lot quicker than trying to actually walk through this step by step, because there are quite a lot of changes to this file. So with that said, let's go ahead and drop this in. Okay. And let's go here to the top of the file. And actually, I'm going to go here and pull up the diff, if I can find it. Where is it? Oh, I already had it selected. Okay. So let me go ahead and collapse this side menu here. So what we basically have to do is we have to add the kthread and kmutex stuff. And then we also have to add pthread, which gives us the kthread and kmutex backends that we need. And the cool thing is because we used pthreads before, or POSIX threads, those actually work on Mac as well. So we could literally just copy over the code that we had on Linux for that, and it drops right in and works. So we need that in Arrow for that. The next thing that we have here is some modifier key states. I'll come back to all this key stuff because that's actually quite a lot going on there. Handle modifier keys, again, I'll come back to that. We've taken our window delegate here. So this is sort of the macOS implementation of the Windows system. So this is all written in Objective-C. I'm not a Mac programmer. I'm not a Mac guy. I am not a master of Objective-C by any stretch of the imagination. This was actually contributed by Jad Tala, or Tala. I hope I'm pronouncing that correctly. 13 months ago, as you can see. So a little over a year ago, he added this native Mac support, and it did work at the time, but it's since become super out of date. And so I do want to take a quick second and thank Jad for all of his work that he put into this, because it gave me a nice platform to, no pun intended, to be able to work on top of, to be able to get this port done quickly. So what we have is I'm basically taking the work that he did for all of the window API work, and I'm basically refactoring that to make it what we need it. So I've taken this window delegate stuff, and that wound up getting moved, so this isn't removed, it just got moved further down in the file. Let's see, this is actually some dead code here, so I can get rid of that. We'll come back to this. That has to do with the key event handling. Okay, so here is that window delegate stuff. So we've just moved that further down. So this is what handles a lot of the events, right? And window initialization. So determining when the window should close, things of that nature. So if we hit the close button, for example, that would trigger this. On the window resize, we actually retrieve some resizing event information here. I should point out that this does correctly handle the Retina displays. So that is what I have here. So that's high fidelity, high resolution displays with a greater pixel density than your typical monitor. This actually does handle that, and that is handled through this content scale right here. So we set this layer content scale to the view window backing scale factor. And this basically tells us what the underlying size should be. So not just the sort of physical size of the window, but what the actual backing swap chain image size needs to be to get that to draw on the screen at the correct resolution. And switching this between various monitors does work as well. So this is what gets that information that's needed on a resize, and then we pass that that larger size on. So this screen is almost 4K. It's like 3.8Ks or something like that. It's not quite 4K, but I guess it's enough Ks because it's clear. So we'll just send all the Ks we have. But in this case, it's basically sending that that full resolution instead of the actual just the window size. Did miniaturize. This is the minimize event. So this is basically just saying the size of the window is 0, which triggers our application to say, hey, we're going to suspend while the application is minimized. And then they call it deminiaturizing. And that is basically the window has come up from being minimized and is now basically counts as a resize. So we basically essentially do the same logic that we did on resize. And then this basically, I believe, just sets some sort of some sort of flag within the window. Again, I'm not 100% sure what all of this stuff does because Jad, thankfully, committed all this stuff a long time ago. And like I said, I'm not familiar with Cocoa, which is what this is using. So I have a very vague understanding of it, just enough to be able to understand what's going on in here. But that's kind of where that ends. Anyway, so that is that. A little bit further down, we have basically taken the view creation that was initially done in that file, and we've moved it above the layer creation just so that that is done sooner. And then down here, we actually have a lot of comments in terms of what getting the actual backing size for Retina displays for the swap chain image and whatnot. So this comment section contains a lot of comments on how all of that actually works. And I think this was actually based on like some Molten VK issues and whatnot. So this was actually something I found basically during my research on how to get this to show up properly and not only take a quarter of the screen or be way too big in the screen or whatnot. This is basically what makes all that the right size. And then a lot of this stuff is pretty much the same as what you'll see in the Linux backend. So, you know, our malloc, our free, our memset, memcopy, all that. Our console write error. Here we've actually modified this platform get absolute time because it was actually wrong. It was just returning the machine absolute time, which is actually not correct. We actually need to take that number and essentially divide it by the clock time base. So we take the numerator for the time base, divide it by the denominator of the time base, and then multiply that, which is a floating point. This will give us a floating point. We multiply that by the absolute time that we've achieved here, and that gives us nanoseconds. And then we take that nanosecond and we divide it by 1.0 to the 9th power, and that will convert it to seconds. So there's that. We have our get processor count, which we did not have before. This just gets the process info object and then returns processor count. And then here is our K thread. So this is all of our thread code. This is all exactly the same as what is in the Linux version. So there's literally no need for me to go over this, including all the thread ID stuff and whatnot. Mutexes is the same thing. This is literally just dropped in from the Linux file. So it's all the same code. The platform get required extension names. Since this is running on Molten VK, this is required for macOS. We have to add one more to the required extensions, and that is this VK KHR portability enumeration extension name. And this is an extension that is required in order for Molten VK to provide the proper device when we go to enumerate the devices. Okay, so the translate key code, I added a trace here. I should probably actually get rid of that, but basically a lot of these were plain wrong, and actually this is not a to-do anymore, and actually I am going to get rid of that. So I put a couple links in here to the Windows virtual key codes, as well as the key codes that I had to dig and dig and dig and dig and to be able to find for Mac. And I'm actually going to really quickly show this to you guys. So this is from a blog post that I found that actually has all of the key codes, and you can see that they are completely different, both from Linux and from Windows. So I actually had to go through and map these one by one. Like A is 0, for example, and S is 1, and D is 2. They're completely different key codes from anything else I've ever seen. And this is the only place that I could find it, which I guess is a upscaled version from a very, very old Apple Extended Keyboard 2 domestic layout manual. And this is like the only thing apparently out there that has this. There's no like official list anywhere, at least not that I'm aware of. I couldn't find it. And so I painstakingly went through and mapped every single one of these key codes to our key codes within Kohi. So that is what all these changes are. There were a number of them that were correct, but there were a number of them that were also completely wrong. So that is that. And with that, I believe everything else here is actually revolving around keys. So that brings up the next bit about keys. So the other operating systems that we have, the modifier keys like your Shift, your Control, your Alt, your Windows key, things like that were all considered key presses. They all showed up for key press events. And on Mac, that is not the way it works. On Mac, they are modifier flags. And so when that modifier flag value changes, that is when we actually get the event. So back up here, this flag's changed. Thing that I skipped, this is actually what gets called whenever one of those keys gets pressed or released. And so what we do is we take the event key code and the modifier flags from the event, so that's out of this NS event object, and we process those things in our handle modifier keys. And we basically look at each one of the keys, and we run it against a number of masks and codes to determine what version of that key is being pressed. So on most keyboards, there's a left and right shift, a left and a right control, a left and a right command or super key or Windows key. Same with option or alt, right? And so we need to determine whether the left or the right one of those things is pressed, whether it's already been pressed, whether it's already been released, etc. And so those have to be handled in a state completely different. So this is a function that basically analyzes for shift. So we do shift, control, alt or option, command or super, and then the caps lock is handled a little bit different because we're saying a process input key of true is when caps lock is turned on, and false is when it's turned off. And so basically what we do is we take the NS key code that's passed in and the modifier flags, right? And we take the key codes, the Mac key codes, the modifier flag shift mask, and then the key codes for left and right shift for Kohi, the modifier, so the bit shift for left shift and right shift, which is a different value for, let's see, where were those? It's a different value for each key. So for like shift, for example, it's 1 shifted by 1 bit. For right shift, it's 1 shifted by 2 bits. For left control, it's 1 shifted by 0 bits, but for right, it's 1 shifted by 13. And this was actually something I found online, that somebody actually sat there and painstakingly found these. And so basically, this is a mask that you use to determine whether it's the left or the right key. With that, there's also a modifier here. So if we look at this, this is basically a bit flag that we are using to set the state of that individual key. So we have 8 individual flags that we modify here. And since we actually have 8 of those in our state, where is it? Oh, right here. We actually have a U8 that we store all of those in. And so we actually just AND these together, or them together rather, when they're on, or flip them on or flip them off. And so each one of these is represented by a single one of the 8 bits that is in here. And so what we do is that is how we determine whether or not it is currently pressed or released. And this function down here is what helps determine that. And so we take all of that data for each key, right? It varies slightly for each key, the codes and all that, and the masks. And we run it through this logic. So we have our modifier flags, which we compare against the key mask, which is either this NS event modifier flag shift or control option command, right? And that tells us what key it actually is. And then we get we check for the left variant, and if we find it, we return true. We check for the right variant, and if we find it, or we call process key true, right? So if that's actually set, then we know that it is true. We only do this, however, if it is not already pressed. So we also check the modifier key states and the L modifier. So we check to see if that flag is actually set. And if it is not set, we go ahead and set it and then say, okay, this key has been pressed. So we do that for the left, we do that for the right. If the key mask is not set, then the next thing we have to do is check the key code against the left key code and the right key code. Say, okay, well, is the key code passed in? Does that match, the left or the right key code? If it does, check the key state, again using the mask, to see if that bit has been set. If it has been set, then take that mask, flip all the bits, and then AND equals it. And this basically just flips that bit back off. And then we go ahead and report the release passing false here. Okay? And so we do the same thing for the left and the right. And that is basically that. That is how that works. I don't think I've missed anything in here. I think that is basically the gist of it. So, a lot of this, like I said, has been in place for quite some time. I'm not going to go through this entire file because, again, like I said, it will take a really long time. And frankly, we just don't have that kind of time. So we're already about an hour and a quarter in. So let's go ahead and build. And right, so we have actually we've updated some of our key definitions, right? So we have some keys in here that that don't actually show up yet because we don't actually have any of those things defined. So we actually need to go to what is it? I think it's input.h. Yeah. And I'm actually going to, again, just paste in some code, and we'll look at the diff. So we originally had these key called key prior and key next. That's page up and page down. This is what Windows was calling it, was prior and next. That's where I got all these from initially. That's kind of stupid. So it's page up and page down. So we changed those. We added the print screen. We renamed snapshot to print screen. We renamed left and right windows to left and right super, because that's just more platform agnostic. Put a comment in here for the apps key, which is that sort of submenu key that some Windows keyboards have. And then we've gone ahead and added a couple more keys. So we changed the key code for the semicolon. That was BA, and that should have been 3B. And then we have the apostrophe key that we added. And then we also added an alias for that called quote. Just because that's sort of on American keyboards, that's what it is. So it's a single quote. And then we also changed the plus key to just say equal, because that's sort of the primary key. That's the key next to backspace on most American keyboards. So that's that. Then we added the left bracket, the right bracket, the pipe key, which is also the backslash key. So we added an alias for that. And then at the bottom, we added a convenience function to get the input string for a particular key code. So because we have that, that means that there is a small change to our input C. So let's open up that. And I say small change, but it's actually kind of a big function. So it is this guy. And this basically just takes all of our key codes and maps them to a string and returns it. That's all it does. So, these strings don't necessarily mean anything. They're just kind of names I chose as string representations. That way, when we actually push those keys, we can actually get meaningful output instead of sort of some garbage key code translated as ASCII, which is just wrong. Okay, so let's try and build again. All right, and we've built this time, but I can tell you right now we're not going to successfully run, but I'm going to go ahead and run anyway. And let's see. So we've gotten, as I mentioned before, we don't have terminal output. Unfortunately, we have to use this debug console here. So, point a few things out. Let's see. So right here, we see here that we have a window resize of 2560, 1440. That is double the resolution of 720 by, 1280 by 720. So you can see here that we have a content scale of 2. This is all stuff that's output, by the way, by the Molten VK. Let me just check something real quick. Okay. So, so we can see here that we have basically a pixel density of 2. And then we get down here and right here. So we have Vulkan instance creation failed with result, VK error incompatible driver. And so this is one of the things I was talking about, that if you don't set up flags and extensions correctly, this will happen to you. So this is basically causing our renderer to fail. So there is a small change that we need to, I believe it's the back end. So let's go ahead and take a look at let's back end. And again, I'm just going to paste and sort of look at the diff here because we have a lot of changes to files overall. So one thing that I noticed is this needed to be moved. So this is the required extension count. If we do not build debug, right, that was being defined in here. And that would cause it to fail to build because we later use that right here. So that was one thing that we had to change. And actually, I think it might have been in device. It might have been device that we had to do. We did need that change too, but was it? I thought it was back end. So let's see. So we have the it might have been swap chain actually. I'm struggling to remember where all the changes were that we actually had to make. I think it might have been swap chain. Apparently was not swap chain. Let me see. So I'm trying to remember. Where that change was. I thought it was in. I think it is in Vulkan backend. Am I just missing? Oh, yeah, here it is, right here. Okay, so this is the other change, which unfortunately requires us to put some platform-specific stuff in here, but there's really no way around it. So if we are on the Apple platform, we have to add to the instance creation info this flag, which is the instance create enumerate portability bit KHR. So we have to add that guy. And let's see, was there anything? I don't think there was anything else that actually changed in this file. So let me actually build this again. And we'll try running and see where we get. And hey, we are up and running. And so I'm going to switch over to the debug console here. And I'm going to press a few keys, right? I'm going to load the things just to see that we have everything here loading, right? We can see here that since we're running at such a high resolution, our text is kind of small. So we may eventually want to put some sort of text scaling in for that, but that's sort of an indication of what this high resolution is doing for us. But I can go through here and press all these individual keys now, and we get our rendering modes as we expect. We can see we do see some garbage here though around sort of when we press the shift keys and things like that. So let's go ahead and fix that. And actually, I want to do one thing in application as well. So in application, we had mentioned before that we had put our versioning stuff in. And we need to go ahead and actually add that. So what this is I've actually changed this logger include to be core logger. I don't know how this was working before. I guess because application is in core, but I've changed that to be more explicit. We're also including our version.h, which we'll note is being generated by the build process down here. So we see that's being generated every time we build. And so basically, let me go back here to this view. So we have that. And then if we come down a little bit further, we are going to report the engine version, right? So we're just going to spit out that K version there. And there's one other minor change, which is down here. So in our key press, we're going to call our input key code string, and we're going to pass the key code. So instead of just saying the character itself and treating it as an ASCII character, we're actually going to get the proper string from the key code and use that instead. So let's build, let's run again, switch to debug console, get that back, okay? And now when I press left shift or right shift, you see here that we actually get meaningful text, right? And so I can press a whole bunch of keys, right? I can press option, I can press super, right? The function key I don't think is actually going to do anything because that gives me emojis and whatnot. So it doesn't recognize that one. But our control keys work, our arrow keys work, our backslash, some of our special keys that we had to put in, all those things work. Okay, so there is a little bit more that I want to do, but I think this is actually where I'm going to draw the line on this video for right now. And I'll move some of those other changes to the next video. So I think this has gone far enough. This was kind of a long video. If you guys have made it to this point, congratulations. I will try to keep the next video to not be quite as long. But let me know what you guys think about, the sort of high resolution video. If this is something you guys want to see going forward, and you want me to continue with, then let me know. If you don't really care, let me know that way too. Because of course this does take a lot of extra storage space and whatnot to maintain all of this, to record and to edit and whatnot. So there is a little bit of extra effort involved, but, if the quality is worth it, then it would be good to know that. Anyway, that is going to do it, I think, for this video. So thank you guys so much for following along. It's great to finally hit this milestone where we have, the Mac platform officially supported. And so from now on, I will be supporting this platform fully, just like the other two. So thank you guys. Please leave a like on the video. Let me know any feedback that you have. And if you haven't already, consider subscribing. Those subscriptions definitely help me out. It helps with exposure of the channel and getting it to more people. So that definitely really helps me out. And that's about it. See ya.